Okay, Bismillahirrahmanirrahim. Professor, can we start? Okay, Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wabihi nasta'in ala umuri dunya wa din. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin. Wa ala alihi wa sahbihi ajma'in. Amma ba'd. Our presenter, Yang Mulia, Professor Dr. Ahmad OSUMANU HARUNA, Head of Postgraduate Program, Faculty of Agriculture, University Islam Sultan Sharif Ali. Participant for this program Khidmat Academic. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh, and a very good morning to all of you. Without further delay, let's start our program with the recitations of Surah Al-Fatiha. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين 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 يا رب العالمين. Thank you. Ladies and gentlemen, before we proceed with our program, let me share our presenter's profile. Ahmad OSUMANU HARUNA is a professor at University Islam Sultan Sharif Ali, Brunei, and specialized in soil fertility and management. He has diverse expertise in biosystem management, regenerative agriculture, waste management and utilization, fertilizer technology, greenhouse gas emission control in farming system, and soil-plant water interactions. He serves as an expert reference at national and international levels. He is involved in several research projects which have produced patents, commercialized product, licenses, royalties, trademarks, books, book chapters, referred journal papers, awards, amongst others. He is actively involved in ethnology diffusion and related professional services. Now, we would like to invite our presenter, Yang Mulia, Professor Dr. Ahmad OSUMANU HARUNA, lecturer of the Faculty of Agriculture, UNISA, to begin his presentation with the title Soils of Brunei, Their Properties and Effective Management in Modern Agriculture. If you have any question for our presenter, you may give your questions in the chat box. Inshallah, I will read it during the Q&A later. Thank you.
Assalamu alaikum, everyone. The chairperson, thank you very much for the kind introduction. And we're also very grateful to see our audience. And inshallah, we try to share what we have. And then from there, we will have some open discussion. Please, is my voice audible? Could you hear me clearly?
Yes, Prof.
All right. Well, like the chairperson put it, we're just trying to see some of the striking properties of Brunei soils and perhaps how do we contribute to their management. Now, if we look at it closely, perhaps I'm going to run you through two sections. One is to introduce the soils and then the unique properties, their management and other things. So soil formation in general, as we can see, soils are formed from what we call parent materials. Like human beings, we have our parents, so soils also have their parents. So the material from which soils are formed is what the material is called what? Parent material. There are different types because these parent materials would determine the quality, the properties, whether physical, chemical, and biological properties of the soil, for that matter, the fertility status of the soil. So then we can say that some soils are formed from rocks and minerals. Others are purely formed from organic materials like plant and animal waste. And some also can be formed from volcanic eruptions, volcanoes. There are different sources, but I'm just, for the sake of this talk, I'm giving only three. Now, this is a classical example of volcanic eruption. So for human beings, we might think that is negative, but with time, it turns out to be one of the most fertile soils in the world. So this is an example. Now, soils which are formed from what we call decomposition of organic materials, these soils are generally called organic soils. I'll go deeper into this. And for that matter, for soils formed from rocks and minerals are called mineral soils. So we have two broad categories, and later we'll zoom down to 12 of them. Now, being the case, if soils are formed from minerals and rocks, then we would like to see some of the examples, because these are the parent materials and they are going to tell us about the soil status. We also have granite, augite. These are common ones that are formed in Brunei. Quartz, we are talking about feldspar, biotite, hornblende, and others. I'm not going to go into the scientific part, but I'm bringing this later on. You will see why some of the soils are acidic, and in certain situations, soils are basic. This is very, very important. Now, coming down to acidic rocks and minerals, if you are found in an area where most of your environment are, their underlying materials are acidic, and then at the same time they are mineral in terms of rocks, then the soil that is going to form there will be different. I give you a classical example. If you see like granite, granite contains iron, aluminum, and a bit of silica. If you see quartz, quartz contains a lot of silica, and later they form salicylic acid. So these are the kind of rocks that will later decompose and then produce what we call the acidity of a soil. Now, sometimes also you will find yourself in a place where we have pyrite. Pyrite is yellowish, the one you call fool's gold. It's like gold. If you find yourself in that kind of environment, your soil is going to be very acidic, and usually you might end up producing acid sulfate soils. So these are some of the examples that I'll be talking about. So there are different types. And in Brunei, these things are quite common. Sometimes if you don't see this, elemental sulfur can also cause soil acidity. Now, what about soils that are alkaline, which are not very common in Malaysia unless you are maybe in the coastal areas? But generally, if you have a basalt, this is a kind of rock which is very alkaline, contains a lot of calcium, magnesium, sodium, and potassium. So this is one of them. And then certainly we have limestones. Limestones, therefore, if you have an area with a lot of limestone, then the soil that will be formed there will not be acidic, but it will rather be basic. Now, if we say formation of mineral soils, there are three things that are involved. I'm not going to go to the scientific part, but we know the physical breakdown, the chemical breakdown, and then the biological, which will be the microorganisms and the biological aspect. They will break down your rocks and minerals, and so can they do also for the organic materials. Now, if we look at it closely, because I'm going to refer you to the type of soil, I just want to draw your attention to this part called soil profile. Soil profile in non-technical way is when you have a 1 meter by 1 meter and you dig through the soil until you get to the rock. You see, the soil is on top of a rock. If it's a mineral soil, so until you get to that level, you will see certain layers. So that kind of profile that you dig, this is what we call soil profile. So this is it. Let's say you go to a field and you dig a soil, you go vertically until you get to the rock. So the layers that you see are called what? Horizons, or some people call it horizons. So these layers can tell us a lot about the soil and then the properties. So you don't need to know what is A, B, C, or whatever for the time being. You just have to understand that soil has certain layers, and these layers are called horizons. So this is an example where you dig a soil and you want to see from the color of the soil, you will be able to know what is it there, what are the properties, what will be the quality. For instance, if you look at this pit, the hole, you can see two striking layers. You can see this top. This is one layer called horizon, and this is another layer. Depending on the maturity, the state, and then the geology of the soil, you might also have certain layers. So example, you can see here one layer, two, three, and four. So all of them tells us something different. Why some are white, some are dark, some are brown, some are red. These are the properties that will tell us the quality of the soil. Now, coming down to the global scale, in the whole world, we have 12 major classification of soils. We call them orders. So out of this, every soil that form will be able to describe how it is. For instance, when you say it's alphy soils are normally formed, these are forest soils. And then let's say, for instance, ND soils, these are soils from volcanic eruption. Aridi soils are soil from the desert. NT soils are young soils. If you talk about jelly soils, these are soils that are formed from, where there is some sort of freezing and snowing or whatever. And if you talk about histosoil, will be organic soil. Inceptisoils are soils formed in higher altitudes, but they are just like a younger brother of NT soil. And then when you go down to, let's say, the other soil, we have molly soils are soils from grassland. And you talk about oxysoils. These are the kind of soils that are formed with high aluminum iron, and also the color look reddish. Spodosoils are soils that are sandy in nature, but when you dig through, you will see a concrete. That concrete is called a headpan. And then we have altisoils are one of the older soils where again, you can see some acid sulfate soil coming with altisoils. Sometimes you can see iron and aluminum. I'll show you them later. And vertisoils are also called soils that are cracking. They are, when it rains, they swell, and when it dries, then they will crack. So that is called vertisol. So these are basically the orders. But when we zoom down to Brunei, not every soil that is in the world can be found in Brunei. For instance, Brunei has no desert, so you don't see arid soil. You don't have volcanic eruption. Therefore, you don't see ND soil. It doesn't snow here. You don't have jelly soils. So what are the soils that are generally found in Brunei? We have oxysoils, alphysoils, antisoils, spodosols, and then vertisols, and for that matter, altisols. So you have 8 of them, histosol and inceptisols. Well, so now let me walk you through one by one for their characteristics. Now, when you talk about alpha soil, generally, these are soils, they are moderately acidic. They are not very, very acidic. You can see the pH range, and they are light colored. So meaning that they form in an environment where it is not very, it is, of course, there will be rainfall, but the temperature does not exceed 35 degrees. And these soils are forest soil, they are quite rich. There's less leaching. When you say leaching, losing of your nutrients from the soil profile. And because of this, they are considered to be relatively rich because they are always found in the forest, right? So this is an example. So when you dig a soil profile, you can see, this is why we say they are light colored. You can see the organic matter here. So this is the fertile part, and this is the clay part. So you can see here it's well distributed, and then you can see the clay here. So I'll come down to that later. Normally, because these soil generally they form in the forest areas or whatever, you don't need much of agronomic activities to do much, but of course, you can do crop rotation. You can use a little bit of tillage implement to prepare your land. And then you can have not a moderate type of fertilization will do. Because generally, these kind of soils, they don't have much problems like other soil that I'll be talking about. Now, the second soil is what we call anti-soil. You see, in soils, we have young soil, middle-aged soil, old soil, and older soils. So this is one of the youngest soils. We call them what? Anti-soils. Now, these antisols, normally, they don't have well-developed layers. So you see only one layer, and the rest of the layer, you will not see anything because it's young. So just think about a human being who is young. So it's trying to develop. So that is how it is. So because of this, it's also formed on rocks that are quite soft. Some of them may also form on rocks that are quite hard, but generally you find them in floodplains, and then you find them also in hilly places, and then river valleys. So this is an example. If you see this soil, it looks like it's a sandy soil. Yes, especially floodplains. So you see here, you don't see much layers. The whole of this looks like one layer, and then the top here is where you see the organic matter. So this is what we call an anti-soil. It's trying to go through formation, and many, many years later, then the layers will be formed. Now, like I said, they occur on steep slopes, river valleys, and sandy areas. This means that the soil is not stable. You can imagine a soil forming on a steep slope. They will be always moving on and off. You get it? If it's valley, there will be deposition all the time. So this is why we say it's not a stable soil, and you need a lot of practices to handle it. Of course, their pH can range from where you find them. If it's around the coast, it'll be different. If it's interior, it will be different. Now, what are the challenges in dealing with empty soils? One, because they are sandy in nature and they are constantly undergoing formation, they lack organic matter. Nutrients are low, and then the soil cannot hold water very well. When you have less organic matter, of course, definitely you can. Therefore, it has a loose structure. So when a soil is loose, you expect some erosion because it occurs along some slopes. So there will be some erosions. Now you need to understand this for a way to manage them. So when you have a soil like this, the water holding capacity will be low. That means I cannot hold much water. And then there will be drainage, especially when it forms around the valleys. Then you need to do some drainage to drain some of the excessive water. Now, also because they lack organic matter, so you will see that this is why sometimes we recommend organic amendments like biochar, compost, and other things, just to improve the quality in terms of water holding capacity and nutrient availability and other things. And sometimes you see that one of the other means will be to grow cover crops. You get what I'm saying, like Mokuna, Brakata, and then you grow cover crops, and then you can what? Manure it and then re-plow it into the soil just to build on your organic matter. So these are some of the things. If you can do that, then we can enhance the fertility. Of course, sometime where you have less rainfall, then irrigation may be important. But when you talk about irrigation, then we can talk about drip or sprinkler irrigation. This is to enable us to conserve water and then improve crops growth and development. When it is in the flood plains or maybe in the river valleys, then you need to drain because under that circumstance the movement of water might not be good. Again, if it's around slopes, we have to do contouring, we have to do tracing if we want to really avoid erosion and manage water. So the third soil, before we go into the practical aspect, will be inceptive soil. Inceptive soil is next to empty soils in terms of age, in terms of development. So it is an elder brother of empty soil. So if you look at them, as again, because it's going through formation, one of the key management practices will be for us to control erosion. And the number two is for us to control what? Drainage. This is very, very important because they occur in mountainous areas. So in certain part of the world, they will prefer to leave it intact for forestry or recreation or conserve water where there are river mouths and whatever as watersheds. Right. So this is an example. So you can see that as we move on to empty soil, there's a clear difference now. You can see this is the A horizon, the top part, and then you can see down there now, there's a two distinct area. But when empty soil, normally everything will just jam up because it's going through formation. So you can see here, this is the difference, and then you can see here. So these are the examples. What are the characteristics? Certainly, they are young soils and also they don't have many horizons, but they have what you call B horizon. When we say B horizon, this area is the B horizon. But empty soil would not have that clear one. Now, coming down, they can also be found on rocks or any small, geological surfaces, but they do best when we leave them for recreation, forestry, and then other kind of management. But if you want to grow crops, then we need to have some sort of management. One of them is to what? We need to have some drainage system because they can be saturated, because especially you see them to be grayish. That means that there is too much water and we need to have some drainage system, which I'll talk about. But generally, they are fertile. They are far better than empty soils. They can have about 10 to 31% organic matter. And of course, they are a bit sandy. They have some clay, so we can grow. But it's just that we need to manage the soil very well. And the pH is also relatively acidic to neutral. And the only thing is, if you want to grow something like paddy, will be a problem because it's in mountainous areas. So that definitely doesn't make sense to do that. What are the management practices? Of course, they also occur along the slopes, right? So we can look at the terracing, the contouring, and all this. And the definitely drainage system is important. Much as they can have some their own organic matter, if it's for agricultural purposes, then fertilization will be necessary. Later, I'll talk a detail about what type of fertilizers and the like. So these are some of the things. And then we can also say that we also have to be conscious of the environment. If you really want to maintain the environment, then it will be better we don't really go much into insectisols. But if we don't have a choice, we can do that. Then number 4 is what we call the spodosols. They, like I said, the spodosols, these are the soils where iron, aluminium, and then organic matter, they combine to form a concrete. So if you go to the first layer, you will see organic material. The second layer becomes like a concrete. And this is quite serious because when you have a soil like this is what I'm saying. You see here, this part organic. But as you move on, this is iron, aluminium, and organic matter combined together. So this is a hard pan. We call it spodic horizon. So when you have this, you're going to have problem. You see, this plant cannot penetrate. So in certain management, you have to break this pan before you do cultivation, and it's going to cost a lot of money. So this is why it's very important for us to understand the basic information about soils. So this is the spodic horizon. You can imagine growing crops and you didn't know this layer. So these are the challenges, right? So now the spodic soils, like I said, generally they can be acidic around 5.5, and then the organic matter can be very low. And the bulk of the second layer will be concrete. And in certain situations, they can even be acidic on the top, but as you go down, it becomes more acidic, as you can see from this. Now, because of this, we can say that they are infertile. So if you want to cultivate it, if you really have money, you need to break the pan, the hard pan. And then, of course, you can add organic amendments and fertilizers and the like. I don't want to highlight on these fertilizers, and later I will be coming down to give the specifics. And of course, because the pH is acidic, you may want to lime. By what kind of liming, we will talk about that. And one thing about this soil is also like a lot of nitrogen and phosphorus. Therefore, you should focus more on nitrogen and phosphorus. And of course, the water holding capacity, if you want it to increase, then you need to manage your organic amendment. And that's very important. And also, you also have to drain, especially where there is high rainfall. Now, again, if you ask me antisol, insectisol also, for environmental conservation, that would be good because they also occur in hilly areas and mountainous areas. But if you want to maintain vegetation cover as a forest or recreation will be the best. So those are the things that I can highlight on. Now, the next one is what we call vertisols. These vertisols, I think there will be some there. I think there are some in Tamboron areas. You can see these kind of vertisols that you see, they are very interesting. So when it rains, it's a clay, it's full of clay. This clay will swell. And when it dries, when there is no rainfall, there is dryness, they start to crack. So within deep crack, deep cracks are the ones sometimes can cause erosion. So vertisols are very difficult to work with. They are very sticky. You bring your implement, sometimes you might even bog down. They can occur in the savannah. It can occur in the forest. That's why in Brunei you have them. So this is an example of a vertisol that has dried. You can see the cracks. Sometimes the cracks can take even a whole human being inside. It's very challenging to work with this kind of soil. So when you dig the soil profile, you can see all the cracks. So these are the cracks that will let down and then leach your nutrient and whatever. And when you try to use machines, you're going to crack the spore pieces and then they're going to affect it. Now imagine you even build a house on vertisols. You see these cracks. This is because of the soil is not stable. So once it's cracked, then it also affect your constructions. Now the management is always waterlogged if it rains. Therefore, we need to work on the drainage system. And when it is like this, it also affects your roots to take nutrient and grow very well. So that's why you see some of the vertisols plants do not do very well unless you re-engineer the whole soil again. And of course, whenever it swells and shrink, remember that we are disturbing the roots. So even engineering kind of things may also have problems. And because of the cracking nature, it's always accelerating erosion. Now, there are certain methods that have been developed. This is why if you want to work with, let's say like vertisols, if it's paddy, it's a different thing. But if you want to grow other crops, then you have to do broadband and furrow. But that means you have to have batas, and then along the batas, you have to have some furrows and ridges. If let's say like tuber crops and whatever, if you want to grow, then you must make them in ridges just to drain the water. And then some traditional areas, what they do is they burn the soil. So they burn it to improve the quality, but this is not encouraging any kind of environmental friendly environment. So I don't really appreciate that. And then one thing is you can match this kind of soil with the certain crops. What I do know is in certain parts of the world, they use it to grow paddy. In certain parts of the world, they use it to grow maize and other things. Of course, where there is no rain, then they will use irrigation. Now, that is an example. Water storage, I think, as I said, if you are able to improve the soil quality, then the water storage should be fine. Of course, but one thing about this soil, it is a must that you must do split application of your fertilizers, especially nitrogen. You need to split it because sometimes it traps nitrogen and phosphorus in particular. And yeah, so this is very, very important because the soil is sticky and phosphorus cannot move fast. It will trap the phosphorus and you see phosphorus deficiency. So this is why sometimes they use light tillage implement to improve upon it. And others also do what drought tolerant kind of varieties. I think BRUNEI shouldn't be a problem because you have a lot of rainfall. But those part of the world where you have a clear-cut dry and wet season, then they will be looking at that. Of course, in any kind of cropping system, if you can cover the surface of the soil will be most appreciated, therefore cover cropping. But when we talk about cover cropping, we are talking about the crops that will add value to the soil, not to other have problem with the soil. Like if you do green manuring where you use leguminous plant, they fix nitrogen when they decompose, they go through and give you organic matter to improve your soil structure and reduce erosion. Those are the kind of cropping that we are talking about. Of course, some may do mulching. If you do mulching, you don't use a mulch that cannot decompose very well and it's rather going to take nutrient from the soil. So these are very, very important. So we have a altisol, there are two more to go, then we go to the practical aspect. Altisols are very old soils. That's why you always see them, they are reddish, they are very common in Brunei here, and they are clay and then acidic, but they lack a lot of calcium, magnesium, potassium, and sodium. This is why when you apply a fertilizer, you hear NPK and the like or whatever, right? Of course, they are found in the humid tropic and the tropics. That's why we find them in Brunei as well. And though they are good for forestry, usually we have turned them into agricultural land, arable land, by trying to improve upon their quality or their health or whatever. So this is why you see when you grow, you always hear about lime, you always hear about organic amendment like compost or whatever fertilizers, because naturally they are suitable for what? Forestry. Now, if you want to handle this kind of soil, the first thing to do, of course, when you do your survey, you need to take samples and you can see the depth 0 to 20 or 0 to 25 or 15. These are the area that you should concentrate, especially if you want to grow paddy on this, then you need to know all these kind of things for you to be able to settle the score with the management. Now, when you talk about fertilizer and lime recommendation, I will come down to that. But for you to do that, you need to test the soil first. And you know what are the nutrients that are limited. Then if you also look at the pH and then the calcium, magnesium, and sodium content, it should be able to advise you as to what to do. And if you want to manage it or regenerate it further, you can do mixed cropping where you do green manuring first before, or you can do rotation and then you manure the soil as you move along. There's something like that is also accepted. Of course, you have compost and other organic amendment like biochar also be there. But if you want to be very intense in the management, then it is always good to ensure that the surface is covered with organic sources. So green manuring and cover crops, crop rotation will also help, or even mixed cropping will also do. And definitely you don't have a choice, especially in this kind of environment where you have high rainfall, then there will be sort of drainage systems and nutrient availability. No matter what we do, depending on the crop. Of course, if you grow short crops like kangkong and the rest, I don't think you might need a lot of fertilizers. High quality organic amendment should be enough because it's just about 3 weeks to 4 weeks. But when you talk about paddy or you are talking about, let's say, like fruits and other things, grains, then in that case, you might need a fertilizer. But that fertilizer also, we talk not every type of fertilizer. If you are in Brunei, you buy a fertilizer contains so much of sulfur, then you are going to acidify the soil again. So not that kind of situation. We are talking about fertilizers that can release the right in nutrient for you. Of course, slow release fertilizer will be preferable, but sometimes they are a bit pricey. Liming is a choice. And then, of course, they are generally low fertile, and then you need to manage them. The acidity is also there. That's why later I'll talk about what are the kind of liming system, or what do we do that we can combine lime and other things to make it better. And because it contains less organic matter, you might also have leaching of nutrient going out. And this is one of the reasons why they are always acidic, because of leaching of base cations. Oxysols are just in the group of altisols, but the difference is oxysols, they fix a lot of phosphorus. So you will see in oxysols, normally you might have phosphorus deficiency because of iron and aluminum fixation of phosphorus. So, and then later on, you will have to decouple them and then bring them back. And then, of course, they occur in the tropics and the subtropics. Brunei is a humid tropic, therefore it is found here. And this is an example. This is a picture that I took when I was in Malaysia with some of my students. You can see this is a classical example of oxysol. So what you see here is actually iron. And these are all what you call eluviation. This is not sulfur. Sulfur will be different thing altogether. Right. So this is it. You can see the layers clearly. So this is a classical example. And they can be so reddish because of iron. And then this is it. So this is how they look like. What are the characteristics? Like I said, they are high in aluminum and iron. And then they also have clay. But the only thing, the fertility is low. And then there will be P fixation, and you need to settle the score of P fixation. This is why you see that they are always being lime or whatever. And then also you need to apply fertilizer because they are poor in what? Calcium, magnesium, nitrogen, and potassium. And like I said, organic matter can be low, therefore you need to improve upon it. So these are some of the things. And of course, you need to cultivate it. If you want to conserve it, then you will have to have some tillage implements and the like. So these are the things. The last part is histosol. The histosol is an organic soil. So in Brunei, you may refer to it as what? Peat soil, the one you call Tana Gambut. So this is an example. So they contain high organic matter, but they are very high in water, and because they occur in pits and in swampy areas, therefore you can see that there will be a lot of water. And basically they are formed from organic materials. And this is an example. This is a very simple way to demonstrate how pit soils are formed. If you see pit soils, they have dome. This is what we call a dome. How does the dome form? You have a valley. So let's say you have this plant, When they die or some of the debris fall into this zone, when there is less water, they will start to decompose. When the water comes, then it will stop. You get what I'm saying? So let's say like intertidal kind of situation. So this process continues for many, many years. So slowly, you will see that the decomposition will be increasing until this place is blocked. And then you can see now trees growing back. This is why when you are in the middle zone of pit soil, it's very deep. But as you go along the edges, then they become shallow. So this is classical example where you have the pit soil. So this is how it is formed. Now, this is an immature type of pit soil. So you can see it's going through different stages of decomposition until it gets to this level. So the top here is a pit soil. Now, and underneath is sometimes you have a mineral soil. You see how yellowish it is. This tells you that this place contains sulfur. So it's likely that this place might have acid sulfate soil. This is why you go to some of the areas or paddy areas, you see some of them, peat that has been with acid sulfate soil. So when you have this kind of situation, liming alone is not going to solve the problem. Fertilizer alone will not solve the problem. You need to work on what you call it, the drainage system. It's very, very crucial. Right. So let's move on now to the next stage. Now, when we get to this part, let's say if you want to understand why you have peat soil in Brunei, peat soils we have the temperate type and then we have the tropical type. So in the tropics, it forms between latitude 35 degrees north and south. So if you see, if latitude 35 degrees north is here, south is here, then Brunei is here. So this is why you have it there, right? Now, as we can, you can use this for so many things. At its natural state, one of the best crop will be sago at its natural state. But if you want to crop it, then vegetables, you need to really work on it, and it's going to be a bit challenging. Of course, pineapple is suitable, oil palm in Malaysia and the like, corn. But if you're really going to go into paddy, from my whole life, I mean, the only country that I have seen has been successful in growing paddy on true peat soil is Japan. But that one, it involves a lot of engineering kind of activities. Drainage is one of the things that is very essential in peat soil. If you don't have a good drainage system, the whole peat soil will subside. Sometimes it can burn on its own, and sometimes it can completely collapse. So these are what we call as, you see, these are some of the limitations. And if you over drain it, it will oxidize very fast to what? To undergo subsidence. So that is really not appreciated. So what are the kind of drainage system? There are two types if you really want to handle it. One, you have to see the depth of the pit. If the pit soil depth is less than 1.5 meters, then you should have three type of drainage system. Along your farm or along your area, you must have what you call main drain. Main drain means the one that will control the water from the pit outside your environment. That will be the main drain. Then you have the secondary drain. The secondary drain will be inside your premises. And then you have the tertiary drain. So this tertiary drain will supply to secondary drain, and the secondary drain goes to the main drain, and it will send it to the national grid of drain. So this is when you have less than 1.5. So maybe you want to grow vegetables or shallow rooted crops or whatever, but I'm not advising you to open pit soil for this kind of activity, just for your information. But if the pit soil depth is more than 1.5, then you must have a ring type. You see here, the ring type. So this will be the main drain. This will be the secondary drain, and this is the sub drain, let's say if it's your field. Now, the interesting part of this is you can have a weir here so that when there's too much water, you open the weir, the water will go. But if it's getting dry, you close it and the water will backflow. So this is very important. Otherwise, the pit will collapse. So this is an example how the drainage system is set up. Right, you can see how much of water you have to drain or how much of water you have to backflow. Now, you see peat soil as an organic soil. Normally, when we say something is organic soil, it's not really fertile. Peat soil is not fertile. It has a lot of deficiencies. So I will talk about them very soon. Now, water management is a must. It cannot take heavy implements like bulldozers and whatever, they will sink. So normally we use light kind of thing. And if you don't manage them also, they can emit greenhouse gases, especially carbon dioxide. You know, it's one of the best reservoirs of carbon. So we need to handle with care. If you want to grow cover crop will be fine, rotational crop will be fine. If you just want to set aside or whatever. Now, because we are talking about regenerative agriculture or whatever, people would like to leave the pit soil at its natural state, like agroforestry, afforestation, or just let them support what they can support in the ecosystem. Example, sago. And then sometimes also the traditional type of farming without disturbing the pit ecosystem is now being enforced. And now let me walk you through subsidence. I took my time to talk about the drainage system because if you don't do it well, this is where you go caught up with subsidence. If there is poor drainage, system and subsidence sets in, it can cause flood. It can also destroy communities. It can also destroy infrastructure. So it's not about your farming area. So this is an example. This used to be the level of the pit soil. In 1983, by 2005, you can see how much of the pit has been lost. And this is because of what? Oxidation, decomposition going on. Therefore, you are losing the soil. And when you lose a pit soil compressing or shrinking, that means the productivity is going to be low. This is a classical example of subsidence. Now, also, you see here, Before these coconut trees were planted, the pit was somewhere here. But you see how the pit has gone down and exposing the coconut trees. So this is an example of what you call subsidence. It can even affect buildings. So that is what I was trying to say. Now, even engineers, we say you construct your road and you don't work on the pit soil very well, you will be exposed. You see, there you see these cracks. If you, those of you who have been moving from Brunei to what do you call it, Brunei to Miri, try to observe. You get to certain places where there is like the car is moving up and down or something like that. That means that that place was a pit soil, but actually it's undergoing through subsidence. Right. Now, if what do you expect? If a pit soil is high and is shrinking, it means that the sea level is going down. Therefore, when it rains, then there will be flood. So this is a classical example in plantations where, because of subsidence, you can see you are having the flood going on. And these are all real life situations. And if you are close to that kind of area, then you are going to have this kind of flood. And sometimes also some farmers feel that they burn the pit soil so that they get more ash to improve the quality. That is a very dangerous kind of practice. Even though you increase your pH or calcium, magnesium, whatever, once you burn the pit, we have something called irreversible drying. It becomes like a charcoal, the one you use for barbecue. It's very difficult to re-wet it. So we have to be careful. And sometimes you might end up setting fire, which can be very difficult to control because sometimes the pit can burn from underneath. You see it on the surface, but actually it's also burning down. So these are the realities. Now, pit soil is very loose and it contains a lot of water. So the bulk density is very low. The bearing capacity is very low. So you don't use heavy implement. Otherwise, you get sink and then you destroy the structure of the soil. Another way to look at pit soil is because it is loose and it has no high bearing capacity, if you grow heavy crops on them, you see, this oil palm is supposed to stand upright. But because the soil is loose, it has to lean like that. This is what we call leaning. So imagine you go and grow durian here. This is what is going to happen to the durian. So let us be very careful here. Now, the irreversible drying is what I'm saying like this. You see here, these are all like charcoal. No matter how much water you bring in, it will never go to the original state again. So that's why we call it irreversible drying. Now, ladies and gentlemen, after giving you all these things, these are the reasons why we are trying to say pit soil is not really fertile. One, it has low nutrient retention. That means that when you apply your fertilizer, it does no, through pit soil, 100% pit soil has no clay. So if you don't have clay, which is sticky to hold on your nutrients, in soil science, we call it cation exchange capacity, then the nutrients will be lost through leaching. Number two is it contains less calcium, magnesium, potassium, and sodium. I'm talking about eutrophic pit soils. It's different from monolithic pit soils. Eutrophic pit soil have high calcium, right? Oligotrophic is the one that you have in Brunei. So they don't have much calcium, magnesium, potassium, and sodium. And then, of course, they are quite acidic. Sometimes can be around 3 pH of 3. If you have acid sulfate soil with pit soil, sometimes you can even go below 3. And then they are also deficient, like I said, NPK, they are deficient. And then because of what? A lot of leaching, micro. The micronutrient that you have in pit soil will be zinc, copper, and boron. They are very, very limited. Now, after giving you all these scenarios, the second part is for me to zoom to acid soils because in this country, almost all the soils are acidic. So let's go into soil acidity. Now, if you look at the whole world, the red color is showing where we have acid soils. Where you see like the blue color on the light will be where you have alkaline soils. So let's see. So it is logical for us to say the entire Brunei is acidic because of what the location that Brunei finds itself. So this is a natural distribution. Now, we also classify pH into different categories, and these are very important for management. If you say ultra acidic, we are talking about around 3, and then extreme with 3 to 4, 3.5 forever. Unfortunately, we have some of the Brunei soil that could have a pH as low as this. Of course, then from there you come out whatever. So one thing about pH is very basic, and for that matter, we should really be able to handle how to manage pH. But generally, if you look at most crops, whether vegetable, you are talking about fruits, you are talking about grain crops and the like, normally pH range of 5 to 6.5 to 7, maximum 7, 7.5 should be able to contain them. Of course, if you want to talk about detail about pH, it must be the type of soil and the type of crop. This is just a general overview. Why are we stressing on pH? pH is one of the variables that can cause a lot of problems to your nutrients. Once your soil is acidic, nitrogen will be low, phosphorus, potassium. In Brunei, I think no need to be talking too much about sulfur because you already have acid sulfate soil. Calcium will also. This is what I was telling you just now. If you have a peat soil, you see here, boron will be a problem, copper will be a problem, zinc, and this is common. So these are some of the things. Okay. Now that we have been able to establish this, then what are the causes of soil acidity? There are several times. Some of them are too, theoretical. I'm not going to. So I pull a few that could be practical. One classical example for you to determine why your soil is acidic is to know the parent material. Remember, I did tell you that if you have granite, if you have feldspar, if you have quartz, definitely the end game will be is an acidic soil. So these are some of the examples. I told you, if you just inform you that when you have limestone, then it's going to be basic. So this is an example. These are the real life situation that these are some of the pictures that I took from paddy fields. Some of them we are trying to regenerate them. This is a classical example of a peat soil that is acidic. Sorry, a paddy soil that is acidic, and it's definitely it has a high content of iron. Of course, if you do the later analysis, you might see that it also contains what? Aluminium. So these are some of them. So you can imagine what farmers are going through trying to contain this. If you condition the soil very well, at the end of the day, when you are going to plant, the soil must be grayish. If you still see reddish or brownish spots and whatever, yellowish spots, then the soil is not well conditioned. So what do you expect? If you have a soil like this and you grow paddy, yes, you might get some yield, but you are not getting the optimum yield. So these are the challenges. And if you prolong it, then this is what is going to happen, right? So, for instance, if we feel that, okay, never mind, we just have to go with it, we apply our fertilizers, we will get something. Yes, but remember, your fertilizer is going waste. A chunk of it will go waste. If you have in the soil iron and aluminum and you apply fertilizer, you're expecting all these red cores that are example, phosphorus to be taken up, but they will all be hooked up because phosphorus is negative, iron, aluminum positive. Then they what? It's like a magnet. They take most of your fertilizer and then only a few now is taken by the plant. So what do you expect? And remember, this iron and aluminum will be toxic to the roots and they might destroy the roots. And for that matter, will not be able to take sufficient water and other nutrients. Now, the other aspect for you to understand why in Brunei also the soils will have aluminum is to look at the well map. If you look at the well map, you can see clearly that these zones are the zones with high aluminum. Okay, so these are all from the parent material, so you can see. So this is why Brunei, you will see most of some of the soil will be high in aluminum. And number three, they might also be high in sulfur because remember I said if you have this kind of pyrite or jarosite or elemental sulfur, which come within the what you call the parent material, then you are going to have this. And these are even some of the construction roads. You can see this is very common when you move around. So these are the realities, right? So again, this is not going to help, but this one looks a little bit yellowish. So when you see this is likely to come from sulfur. So if we trace the history, it could be that there could be some pyrite in this kind of area on the lay with maybe like a peat soil. So this is an example. So when you have a situation like this, the one of the best way is to do some drainage to either you want to oxidize everything and wash them or try to maintain the water table at a certain reasonable level. Then that will give some sort of respite. So I'm summarizing it, or what I'm trying to say is, depending on where you see yourself, it will tell us what kind of soil, whether it's going to be acidic, what type of acidity, is it from sulfur, is it from iron, aluminum, and then what is also there. Now, let me bring your mind back to this area. What I'm trying to show you here is how do we fix this? Of course, you can say that we can use lime, but remember, lime, you use lime, is temporary. That's why almost maybe frequently you have to relime, because liming is not really building up organic matter, and it's also going to affect the soil structure later. So you need an organic system that will be able to organize it and then try to lock iron and aluminum permanently. And this is why we stress a lot on organic matter by conditioning the soil, right? Biochar, compost, high quality, or whatever. This is it. If you use organic matter, because it has a lot of negative charges, so when you apply, let's say you apply phosphorus fertilizer, already iron, aluminum has been locked up by what you call it, the organic amendment. Therefore, your fertilizer will now be able to go into the plants, and then the one that you don't want will stick to the organic amendment. This is what we call chelation. This is very, very important. So if you condition your soil very well, this is what should happen. And when you see this, it tells us that the soil will look what? If it's a paddy soil, it should look grayish. Then it means that you've been able to condition it very well. One other source of rain, causing soil acidity is rainfall and leaching. You see, Brunei, we have a lot of rainfall here. So whenever it rains, you should remember that certain basic cations are being leached out from the soil. One of them will be calcium, potassium, magnesium, sodium. So as the rain is going on and the soil percolates, assuming you don't cover the soil and the soil is exposed to too much rain, then there will be leaching. And this is very serious in sandy soils. This is why you see in sandy soil, sometimes it can be acidic, right? Now, what happens? This is just a demonstration. So it's raining. Now you are getting of course, I'm not saying all of them, but because the soils are old and they have less organic amendment, they might not be able to withstand most of these things. I'm not saying all. So if the leaching continues, what will happen is the good nutrients, which are calcium, magnesium, and potassium, they are being washed out, and they will be replaced by what we call iron, aluminum, and hydrogen ions. You get what I'm saying? This is what we call cation exchange capacity. So we are exchanging the good ones with the bad ones, if you don't mind. So iron, aluminum, and hydrogen ions would now go to your roots, the plant roots. So when they get to the plant root, you apply your fertilizer like P, they will hook the P. Therefore, the P will not be that available. And then that's it. So as you do this, more hydrogen ions are being produced. So when they are being produced, they're going to affect the plant roots. So when the plant roots are affected, it's just like bruises. Therefore, pathogens will now come in to attack the plant. So that is a precursor. Then the plants may start to rot and die. So these are the complexities when we really don't have to work on acid soils. Another indication will be when you see purplish color like this. This is telling you that your crops are suffering from phosphorus. Therefore, you need to take action. And when you look into the soil, it may reflect. This is a maize or corn. You can see this is the purplish color. It's also talking about phosphorus deficiency due to phosphorus fixation by iron and aluminum. Sometimes they can even go through the whole plant to show. These are all classical examples. The severity can also be demonstrated in the grains. So that is why when the soil is healthy, the plant is healthy, the human is healthy. So these are the logics. Now, a number of us forget when we say, oh, aluminum, iron, we only think about toxicity. But indirectly, aluminum also causes a lot of production of hydrogen ion. Example, if you have aluminum 3 plus, and it undergoes hydrolysis to aluminum 2 plus, it will release hydrogen. 2 plus to plus release hydrogen, plus to 0. So 1 mole of aluminum will release 3 moles of hydrogen ions. And these are the sources of your acidity. So these are all indirect things. So if you don't, then that's another thing. Now let's come down to fertilizers. The kind of fertilizers we use for too long will also directly acidify the soils. So that's why when you buy a fertilizer, you need to be very careful. If you are in Brunei, you must be concerned. When you buy a fertilizer and the fertilizer contains a lot of sulfur, then if you continue to use a large quantity onto your soil, then you are also promoting acidification, because sulfur will oxidize to sulfur dioxide. when it touches water, it will turn to sulfuric acid. Ammonium fertilizers also, you need to be careful, like ammonium sulfate. Ammonium sulfate in particular, when it undergoes some sort of nitrification, ammonium now can be turned to nitrate, and in the process, you will release hydrogen ions. So, and also we need to be careful with TSP. I'm not saying you shouldn't use them, but you need to be careful because TSP is already acidic. How do we form TSP? You just have to have a rock phosphate, bring sulfuric acid plus carbon dioxide, you produce TSP. That's why when you take the pH of a TSP, it's generally less than 3. So imagine you continue to use a lot of amount of TSP into your soil, then definitely it's going to happen. Even urea, we need to be careful the way we use it, so long as they would end up producing hydrogen ion. But urea is not so serious because it's base and it can produce ammonia if you can control the ammonia. Now imagine you go to the market and then you've seen this fertilizer, and then, oh, the fertilizer is very good. It's a very good fertilizer, 15-15. Everybody is recommending. But what you are forgetting is 15-15-15-10. This 10 is for what? This 10 is for sulfur. So this sulfur is 10% inside this fertilizer. Imagine you're going to use a lot, maybe 5 tons, 2 tons, 1 ton. You can imagine how much sulfur you are reintroducing into the soil, and assuming you crop for the next 10 years. Now, the other part is acid deposition. You know, now we are talking about environmental pollution, greenhouse gas effect, and the like. This sulfur dioxide, nitrogen oxide are all blown into the atmosphere. When it rains, they turn into sulfuric acid, nitric acid, they fall back into the soil, therefore they will cause soil acidity. Now, we, the farmers also, if we continue to use too much of nitrogen fertilizers without care, our main game is, the end game is, we apply fertilizer to get nitrate and ammonium for the plant. But if we don't manage the soil very well, apart from leaching, what we are forgetting is we are leaching nitrogen gas or nitrogen oxide, depending on the oxidation level, into the atmosphere. And then urea also volatilizes. So at the end of the day, when it rains, what goes up comes down. So these are some of the things that we need to be careful. And also crops. Much as you see, you grow your crops, you harvest, you take the product. If you don't bring back the waste or recycle, this is what we call a circular kind of farming. If you don't practice it, the more you harvest, the more you are losing your nutrients. So if you are getting high yield and you are happy and you don't regenerate or give back to your soil, you are mining all your nutrients. And there's going to come a time that you end up applying more fertilizer, and your yield might not be doing very well because the soil quality is down. Right. So, of course, we all think that when you add organic matter is good for the soil. Too much of everything is bad. If you use too much of organic matter in the soil also can cause acidity, because organic matter produces what we call organic acids. So we have to use them in moderation. This is very, very important. So when you see peat soil, one of the reasons for peat soil to be low pH is because it has a lot of hydrogen ions and organic organic acids. Now, in paddy, it's quite serious. You need to be careful. If you use too much of organic amendment in a very large quantity, the soil will become very soft. So when it becomes soft, you cannot use your tillage implement very well. So this is why we have to know how to really fix this. Now, let me move you to what we call a liming, and then from there, I will introduce the contemporary kind of system that we use. Liming is conventional. Any farmer will know what is liming. One of the principal goals of liming is just to increase your pH, decrease your hydrogen ions based on your crop requirement. And also, you want to suppress aluminum and iron if you have them in your soil. And you also want to increase, because you remember when the pH is low, I told you NPK, CEMG, this nutrient will not be available. So when you lime, you are trying to make them released to a certain extent. Of course, if your soil pH is good bacteria will be in the soil. Earthworms will also be in the soil to improve the quality. At the end of the day, you want to improve your yield and get some economic returns. There are different types of what you call liming materials. It depends on the country and where you find yourself. But my advice to you is you have to look at the lime with the good quality. Otherwise, sometimes you might just be ending buying sand plus certain small amount of calcium carbonate. If, let's say, your soil has problem with calcium and magnesium, then it's good to go for dolomite. If you think you have enough calcium, you have enough magnesium, then you can go to calcium. There are different types. But what I want us to look at is before you talk about liming, you need to assess your soil first and know what is the status of the lime in your soil in terms of cations or CEC. So this is one thing. Then you also have to look at the crop. At what pH will the crop be able to, what we call it, take some sort of lime? If your crop does not need lime and it can do well at 5.5 to 6, then it doesn't make economic sense to do that. Also remember, when your soil is organic, it has a lot of organic matter, you don't use too much lime, because if you do that, you might talk about 10 tons per hectare peat soil. I would not recommend peat soil to be lime, because if you feel like how much you need, not less than 10 tons per hectare, which crop are you going to grow unless it's a plantation crop? Now, the other part also is, in chemistry, particle size is very important. The size of the size of your fertilizer, if it's very, very fine, that means that the moment it touches the soil with water, it should try to react. But if you make it like if the surface is too big, then it will dissolve, but it will be very slow. But then you ask me, if it's too fine, if I broadcast, it's going to be in powder form. That's why I have to use granular. So that is very important. And we also have to know at what depth. You see, we tend to spray on the surface because it's cheaper, it's fast, it's fine. But imagine you are dealing with paddy, which has to go to the B horizon to get a clay, and then you just spread it on the surface. It's okay, but the effectiveness might not be that there like is expected. So these are some of the things that I'm talking about. And then the timing. You're going to apply what time? Is it during the rainfall, or are you going to apply the lime with fertilizer? If you apply lime with phosphorus, it's like you have thrown your phosphorus away, because the lime will consume the phosphorus. That's why before you don't have to lime and apply fertilizer at the same time. You have to know the kind of fertilizer you are going to apply. And one of the crucial one is phosphorus. Do not do that. Right. So neutralizing value is very important. When you take the lime, you need to see what is the neutralizing value. Sometimes it can be 95%. That means that the moment it touches the soil, it will react fast. If the lime is going to take 1 or 2 days to react, then the neutralizing value is very low. Solubility means it might dissolve in water quickly. Others, you'll have to look at the cost, the purity, the pH, handling properties. Is it going to be powdery? Is it going to be granular? Are you going to just spray, or how? These things are very, very important. And you also have to look at the method. How do you apply it? Is it going to be surface? If it's surface, you want it to be uniform. Fine, that is fine. Now, what will be the right time? If it's going to rain, then it's not going to help you. So this is very important. But there are the advantages and disadvantages. The advantages is very simple, fast, and it will not cost you much. But the most disadvantage will be when it is going to be expensive. The lime might not go deep into the soil. So that will be a problem. Some say, okay, I will prefer to plow it into the soil using moldboard plowers or rotary spreading. That will be good. It will get good contact with the soil, and then the reaction will take place, 30 to 35 cm. But you look at the practical implication. Not every kind of farming system you can do this. So they have their own pros and cons. This is why some people prefer to inject. You can even inject, but that one also, the machine that you use to inject the soil will be a little bit expensive, and it depends on the kind of crop you are dealing with. So the advantage is the soil will be very mixed, the pH will improve. However, it's going to be labor intensive and it's going to be very expensive. So we must look at the trade-off. Now, this is something that a number of us do not take into consideration. If you're a farmer, you just buy your liming material, and then because we say the soil is acidic, you apply. If we don't test the soil and tell you the right quantity and you overuse the lime, something called overliming will come in. Overliming simply means that you have too much of calcium or magnesium in the soil. So when you apply your fertilizer, P is being taken, it's being hooked up by calcium because calcium is positive, P is negative. So the plants will not be able to take it. Now, too much of lime also will destroy the soil structure. It will make your soil not permeable, so water cannot penetrate very well, and it might lead to erosion. So these are some of the things. The last part is effectiveness of liming is temporary. It's not everlasting, like when you use organic medium. Now, this is what we call overliming. Let's say, for instance, you apply your lime, and then this is the amount of phosphorus you apply, and then iron and aluminum did not. So this is the best way. So if you are in the right region, you get your P, everything will be taken by the plant. So this is when the soil is acidic. But when you overlime, your soil become alkaline. Therefore, instead of the P to go to the plant, they will be hooked up by calcium and magnesium. This is an indication of overliming, right? Now, getting to the last part of the talk will be the contemporary methods. What are the modern way of trying to navigate not only lime? Those are the things. So this is where soil regeneration comes in, regenerative agriculture comes in. Go back to the nature. People will recommend a lot of soil conditioners, organic amendment to build up carbon in the soil, integrated nutrient management. That means that maybe we can use a bit of lime. We use more of organic amendment and less of chemical fertilizers. And then we are also talking about phytoremediation. Let's say like you have your environment where you want to use organic amendment to assist some plant that will be able to extract toxic metals like aluminum, iron. These are some of the things that should be done instead of chemical, right? And then, of course, acid tolerant crops will be also okay. But now we are talking about rhizosphere management. Rock phosphate is the one that does that the game. If let's say like I get my way, I have a farm here, I would prefer to buy rock phosphate. One, it is rock, it's a mineral, and it is cheaper. And when it reacts with acid soil, the reaction is faster because that's the way TSP is produced. So you can buy your rock phosphate, apply it to the soil. Indirectly, you are producing TSP, but not using any company or whatever. But the rock phosphate will break down slowly. And because there will be soil microbes that eat that kind of rock phosphate, we call them phosphorus solubilizing microbes. You see, so here you are harnessing nature. You get what I'm saying? So this is what we call what nature inspired solution. Rhizosphere because it's occurring around the root hairs of the plant. And I will advocate for let's go back to green manuring. But if you want to do this, then it must go with organic amendment. You don't just go to the polluted area and grow like this. You need to assist them with organic amendment. And then, of course, if it's acid sulfate soils, then we might need some regeneration like water management and the like. So I'm going to show you some of our experiences now. Then from there, I'll end my talk. Normally, when we say organic amendment, we have some indices. You don't simply buy. Some of the composts are of low quality. You just waste your money on whatever. We have indices. What you have to check? pH is basic, EC is basic, humic substances is basic. You need to check the ash content. These 3-4 things, if they meet the test of organic amendment like compost, you apply to the soil and it's going to work. So this is an example of what we produce. And what we are going to use it, the benefit will be, it should serve as a liming material, relatively. It should detoxify iron and aluminum. It should also unlock phosphorus for phosphorus to come up and other nutrients to be available. If the quality is there, it should be able to help your soil to hold nutrients so that there will be less leaching, and it must buffer the soil, meaning that the pH of the soil shouldn't be changed drastically. It must be maintained. So if you want it to be around 5.8 plus or minus 5.7, 5.96, it should be there. That is what we call buffering capacity. And then it must serve as a conditioner to condition the soil very, very well. And then once you start to go in, things must work out. I'm not talking about theory. We've done this in several parts of the world. Now we are also practicalizing them in Brunei, but it's going to take us a bit of time as we try to navigate the problem. So this is initial. So when you apply, remember this is just less than 1 ton per hectare. You get it? We're just trying to look at how it works. So this is not a true representation. We are still navigating. At least you can see the color of the soil has changed a bit. But this is where we want to get to. Once we get to this, the color itself is telling us that the soil has been conditioned, the health has been restored, then we can go in. So we've done quite a farm scale kind of thing, about 2 hectares, 1 hectare, we're trying to do it. And in fact, this is the second cycle that we are going in. So these are all kind of things that we are doing, trying to see how we are going to regenerate the soil. And this one we just harvested, I think 4 or 5 days ago. So these are some of the things that I think I'll be able to show for the time being. So it is possible to be done, but of course, we are talking about only soil. There are issues of pests, diseases, whatever. I'm talking about soil. That's where. So on campus also, we try to ginger the interest of our students to just demonstrate to them in a small scale, though not comparable, but at least to ginger their interest. So these are some of, so we introduce this through what we call urban farming. So the students produce themselves. Some are research students, some are undergraduate, for them to be proud of what they are doing. So all these things have been done. Right. We also tried these things in papaya, and then it's also be promising. Now, what you call pineapple is also looking all right. And then this is what we did when I was in Malaysia. We try it in what you call the one you call black pepper, and it also works very well. Now, we don't have a choice. If there is paddy, something called paddy, and they are going to be salt tolerant, then logically we should be able to come out with certain varieties that will be a bit of acid tolerant, like aluminum, iron, sulfur, and whatever. So that is the challenge. We haven't got there. Now, for the last part, how do you manage acid sulfate soils? There are 2 options. One is to drain the soil from its water, because acid sulfate soils are always below water level. So if you want to use this, which I will not recommend, you have to drain it completely and then allow it to oxidize. Once the oxidation is complete, you now send in water to wash everything. So when you do that, you are providing a permanent solution, but there will be some price to pay. What will be the price? It's going to be very expensive. As you drain the water, you are draining a lot of nutrients and the soil health. So you have to restore the soil. So this is one of the challenges. Therefore, if you go for option two is to be able to, you wash a bit, then you maintain the water level, you wash. So if it's in paddy, that means that when you see that the iron is too much or whatever, you just open your system for the water to wash. And then once you wash it, then you bring the new water level slowly. This is where in Malaysia they used to grow oil palm, where they play with the water table. So again, if you do this, you have not solved the problem completely. So it's going to have a devastating effect if you don't manage your system very well. So these are some of the things that I think I will share with you. So ladies and gentlemen, to end my talk, I will conclude by saying that the understanding of if you have a fundamental understanding of Brunei soils, they should be able to help you to have some effective management that will translate into plant productivity, of course, and then you also conserve the environment. This is just a snapshot. I understand it's for the public, so I don't want to sound scientific. So ladies and gentlemen, again, thank you very much for your kind attention.
Okay, thank you very much, Professor Dr. Ahmed OSUMANU HARUNA, for today's very informative sharing session. Alhamdulillah, it is the end of our program, Khidmat Akademik. On behalf of all the committee members and the university, I would like to express my utmost gratitude to all participants and presenter for making this event a success. Okay, let's end our program with the recitations of Surah Al-Asr and Tasbih Kafarah. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر. Thank you, and till we meet again, everyone. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.